Welcome to AsynCode. Want to see more coding challenges? Like and subscribe to never miss out on the latest tutorials. In C++, a pointer is a variable that stores the memory address of another variable. In simpler terms, a pointer points to a location in memory where some data is stored. Pointers are a powerful feature of C++ because they allow you to manipulate memory directly, which can improve performance and enable dynamic memory allocation. This example demonstrates how to use pointers in C++ for managing memory, both statically and dynamically. It starts by declaring an integer variable x and a pointer ptr that stores the address of x. Then it prints the value of x using dereferencing. The program then dynamically allocates memory for an array of 5 integers, fills the array with values, and prints them. Finally, it deallocates the memory used by the array, sets the pointer to null to avoid dangling pointers, and checks if the pointer is null. Include the header file that allows input-output operations. Use the standard namespace to avoid prefixing standard library names with std:. Declare an integer variable x and initialize it with the value 10. This variable is used to demonstrate a basic example of how regular variables work in C++. X is a regular integer variable that holds the value 10. Declare a pointer variable ptr of type int asterisk, which will store the address of an integer. Here, ptr will be initialized with the address of the variable x using the address of operator and print the value of x through dereferencing the pointer ptr. Dereferencing a pointer means accessing the value at the memory location the pointer points to. Output: dereference ptr to get the value stored at x. Dynamically allocate memory for an array of 5 integers using the new keyword. The pointer ARR will now point to the dynamically allocated memory space that can hold 5 integers. Use a loop to assign values to each element of the dynamically allocated array. The values are being set in a way that the first element is 2, the second is 4, and so on. Assign values 2, 4, 6, 8, 10 to the array elements using index notation. Print the values stored in the dynamically allocated array ARR. The loop iterates through the array and prints each value. Access each element of the array using index notation and print its value. I'll put a new line after printing all values of the array. Deallocate the dynamically allocated memory using the delete operator to free up memory. This is important to prevent memory leaks by ensuring the allocated memory is returned to the system. Freeze the memory block that was allocated for the array ARR. Set the pointer ARR to null to avoid using a dangling pointer. A null pointer indicates that ARR no longer points to any valid memory. Setting ARR to null makes it safe, preventing accidental dereferencing of invalid memory. Check if ARR is a null pointer and print a message confirming that. Output message confirming ARR is null. End of the program. Return 0 indicates that the program finished successfully without errors. Return value 0 signifies successful execution of the program. Now run our code. I hope you liked the video. Hit like and subscribe so you don't miss the next one.